Hi everyone, so today we're going to be doing a quick review of the discriminant and how it could help you on the SAT. But before we really get into how it can help you on the SAT, let's do a quick review of what the discriminant is, okay? So what's the discriminant? The discriminant of any quadratic equation is a part of the quadratic formula, b squared minus 4ac. It's the part that we can find under the square root. So b squared minus 4ac is the discriminant. And it definitely can help us. The discriminant tells us, what your teacher probably told you, is the number and the nature of the roots of a quadratic. That means how many solutions it has. Remember the term roots means solutions, x-intercepts, if there are any. All right, so if the discriminant is positive, so if b squared minus 4ac is positive, it can be written as greater than 0. That means it's going to have two real roots, which means two real solutions, which means it's going to have two x-intercepts. So immediately, if I know that a graph crosses the x-axis twice, like this graph here, you can see it crossing the x-axis twice, then I know that the discriminant was a positive number. So the discriminant can tell me about what the graph might look like. Okay, another scenario could be if the b squared minus 4ac is 0, equals 0. If it equals 0, think about it, that value was the part under the square root in the quadratic formula, which means that that plus minus that's in front of it would go away. So that means it would have one real root. We call it a double root. Some teachers might call it two equal roots, which means they're the same. So that means that it is going to have one x-intercept. And it's actually going to, that means if it has one x-intercept, the graph just touches the x-axis once. So this is important. It means that the vertex is the x-intercept. So that's important. Okay, the vertex is the x-intercept. Now, I want to just point one thing out. We're going to talk about it a little more. If b squared minus 4ac equals 0, then that is telling me that my quadratic equation is a perfect square trinomial, a PST, which we've talked about in other videos, a perfect square trinomial. And we're going to talk more about that later, okay? All right, and so then the last thing that can happen, so we've got b squared minus 4ac is positive, which means that there's two real roots. 0, if it equals 0, there's one real root. Now, what if it's negative? Okay, so if it's negative, that would be written as b squared minus 4ac is less than 0. That's how we write is negative. That means that there would be a negative under the square root, which means there's no real roots. Remember, if there's a negative under the root, we have a complex number. We have an imaginary number. So that means there are two imaginary roots. Two imaginary roots. And that's important because it means there's no x-intercepts. But that doesn't mean a graph doesn't exist. It means that the graph just never crosses the x-axis. Look at this one. See? It crosses the y-axis, just not the x-axis. All right, so these are some things that the discriminant can tell me. It can tell me values, it can help me determine graphs, and that's what we call the nature of the roots. All right, so now that we know what it is, how can it help me on the SAT? So here's an example. Find the values of k so that the equation has two real roots. Okay, so as soon as I start talking about roots of an equation, you might need to consider the discriminant. So again, let's talk about that. So if I know that I'm looking for a value of k so that it has two real roots, I'm going to use the concept that the discriminant, b squared minus 4ac, is greater than 0. All right, so now I can identify my a, b, and my c. So a is k in this case, okay? B is 3, and C is 5. Now, normally they're going to tell you K is a constant, which tells me it's a number. Okay? All right, so then I'm going to take these values and I can plug them right into this inequality. So B squared, so 9 minus 4 times K times 5. I need it to be greater than 0. All right, so 9 minus 20k has to be greater than 0. Now I'm going to solve this basic inequality by subtracting 9. So now I've got negative 20k is greater than negative 9. All right, little trick right here. Look, we divide by a negative. I'm dividing an inequality by a negative. What happens? I have to flip the sign of the inequality. So it's going to give me that k is less than 9 over 20. All right, so now I know that any value of k, any number less than 9 over 20, okay, is going to make this equation have 2 real roots, and which means that it will cross the x-axis twice. All right, let's look at an example with a graph. So let's look at an example that has a graph with it. So here we have question number 13. It was on the non-calculator section, which means it's a little bit more difficult and it might take a little bit more work. And this is, it says the graph of the equation y equals 3x squared plus bx plus 5, where b is a constant. So they're just telling me that b is a number, so don't be afraid by that value of b being a constant, is shown in the xy plane above. Which of the following could be the value of b? So this is where I have to pull out my toolbox, and that toolbox of quadratics. So anytime you have something that deals with a graph, you might want to consider the discriminant. And I'd only consider the discriminant if I was only missing one value, like an a, a b, or a c. And in this case, I'm only missing b. So this might be a good place. I also see that the graph doesn't cross the x-axis. Another place that might help me. So remember that if it doesn't cross the x-axis, that means it has no real roots, so they're imaginary roots. So that means that b squared minus 4ac has to be less than 0. All right, so then I'm going to plug in the values I have. So b squared I don't have, so that's I'm going to leave. And then I've got an a, so 3, and I've got a c, which is 5, and that needs to be less than 0. Okay, so then I have that b squared minus 60 is less than 0, so b squared has to be less than 60. Now, in Algebra 2, you might have learned about quadratic inequalities, but I don't necessarily think you need to use that here. This might be a good place now to plug in values. We know that no matter what, if I square b, it has to be less than 60. So I'm going to take my answers and use them. This is a really good place to do that. All right, so if I take 9 and I square it, I'm going to get 81 is less than 60, which is not true. So it can't be 9. So 0 squared, I think you can see, is less than 60, so I have to keep it. Negative 6 squared is 36, which is less than 60, so I have to keep it. And then negative 15 squared is not less than 60, because that's going to give me 225. So I've eliminated 2 of my answers. Now I have to look a little deeper. Again, it's question number 13, so it might not be as easy as you think. If b is 0, then this goes away and I get 3x squared plus 5. Now if I'm to graph that actually is a graph just being moved up a little bit on the y-axis. Remember, if I let x be 0, I get a y of 5. So my graph's actually going to look like this. Now you can clearly see that this graph does not cross the y-axis at 5 right here. It actually, you can't even tell for sure that it does until it gets way, way up. So 0 couldn't be an answer because it would have to cross, it would really need to be symmetrical with the axis, and I know my graph is not. So I would be able to throw out b, and so c would be my answer. So that took a little bit more thinking than just the discriminant. And how do I know that that would be okay? Because it's question number 13. All right, so there's a quick review of how the discriminant could help you on SAT. I'm going to look at a couple more videos. So we're going to call it part 1. And I hope you all have a great day. Hopefully that was helpful.